After having looked at the fundamentals of mobile private networks, in this video we will examine the architecture of a mobile private network and try to understand which components are needed to create one. The simplest way to start visualizing a PMN is by understanding the data network. The data network is where all the information resides. Internet is a type of data network that the users want to access, especially on public networks to get information like news, weather, scores, or to shop, pay bills, access bank accounts, etc. In a private network, the data network is where all the user data for the enterprise is stored. In addition, you could have a cloud or an edge data center that you can access via the data network. Your applications, either on the device or in the private network, talk to application servers that can be accessed via the data network. Generally, the data network could be internal, located on premises, or external, hosted by another company. The next component we have is the core network that connects to these data networks. The core network is the actual brain of a mobile network and is responsible for running the whole network, managing sessions, mobility, connecting to external networks, etc. It also manages the database for all users and is responsible for authentication. The core network connects to the radio access network, or RAN, using the backhaul. In a mobile network, the backhaul refers to the transport network that connects the core network RAN. In a public network, different types of backhauls are used, including fiber optics, microwave radios, satellite connectivity, etc. In a private network, the backhaul is a high-speed Ethernet cable like a gigabit Ethernet or better. If the radios support a fiber interface, fiber could be used as well. The RAN is responsible for transmitting and receiving radio signals. Private networks can consist of an integrated radio node that contains the complete functionality of a RAN node. In public networks, the baseband unit and the radio units are generally separate. You may need a similar configuration in a wide area of private networks, but typically small cells or all-in-one integrated units are sufficient. Finally, we have the devices, gadgets, and machinery that are collectively referred to as user equipment, or UE, that are able to communicate with the mobile network over the air interface. While the public networks rely on a large amount of dedicated spectrum, for private networks to be able to function at their best, a dedicated spectrum is a must. The regulators in many different countries have allocated chunks of spectrum for private networks, which is allowing innovation in the private network space in those countries. We can represent the 4G and the 5G high-level technical architecture as shown here. The 4G core is called Evolved Packet Core, or EPC, while the 5G core is called 5G Core, or 5GC. The RAN for 4G LTE network is called eNode B, while that of 5G New Radio or 5G NR is called gNode B. There's also an intermediate 5G network called the 5G non-standalone, or 5G NSA, which uses the EPC but uses both the 4G and 5G RAN. This is generally an expensive option for private networks and is rarely used. In the next video, we will discuss the differences between 4G and 5G private networks. That's all we're discussing in today's video. We hope you find this helpful. Feel free to let us know your thoughts in the comments below, and while you're here, please hit the like and subscribe button on our channel. If you want to learn more about private networks or our solution in general, you can find us on LinkedIn, Twitter, Facebook, and on our website, firecell.io. Thank you for watching, and see you again soon.